Hello. In this session, I am going to take the fundamentals of mechanical linkages. Firstly, I will take the definition of machines and mechanisms. Definition of machines we will take. Okay, in this one, mechanisms what we are going to use. Okay, those are used in the machines. That's why we are going to take the machines also. And later we will take that is what are the mechanisms. A machine is a physical system using a power to apply forces and control movement to perform the action. Here the physical system it uses the power and apply the forces and control over that forces to perform any required action. The term is commonly applied to the artificial devices. The artificial devices such as those employing engines, motors, different machines like lathe, drilling, milling, like that. These are the we are going to call as a machines. But also natural biological molecules also called also such a molecules of machines are the like human beings. Definition of mechanisms. The combination of force and movement defines the power. Okay, force and movement what is there? That is the power, and mechanism manages that power to achieve the desired set of forces and the movement. That mechanism what is there? It manages that whatever the power is there, force and the movement. Okay, then to achieve that whatever the required movement is there. And mechanism is usually part of the larger system known as a mechanical system or a machine. It is a part of that machine, total machine. In that the number of linkages may be there. Mechanical linkages are there, mechanisms are there. Okay, those are used in the machines to have the particular action in that. We will discuss the different types of mechanisms. And that first one is a linear motion mechanism. Here linear motion mechanism means which will provide linear motion in order to have the larger reduction in the gears as well as the increase in the torque. Okay, in order to have the different whatever the advantage from it. Okay, variation in the speed and variation in the torque. For that we are going to use to convert this linear motion into rotary motion or rotary motion into the linear motion. A reliable low cost rack and pinion mechanism converts the rotational motion into a linear motion. This is the rack and pinion. This is the rotary motion of the gear, and that will convert that whatever the rotary motion of that gear into a linear motion of that pinion rack, that one. Okay, here the linear motion whatever is there, that is used for the different application. Here the direction of rack movement is determined by the direction of the rotation. Okay, if it is rotating in this direction, it will be moved towards this one A. Okay, like that direction it will be determined later. But like this, whatever the conversion of this linear motion by any rotary motion, that is the linear motion mechanisms. Next, that is the oscillating motion. The oscillating motion is the like the motion of the swing or a pendulum. How the swing will be there, how the pendulum is there. Okay, like that the operation whatever is there we are going to get by the mechanism, that is called as the oscillating motion mechanism. Swinging from one side to the other side to side, this is swinging. Here it is a pendulum, it is shown. The pendulum how it is swings from one side to the another side. Like that the swinging movement of the particular the part we are going to get here. The ends of lever exhibit oscillating motion, and this arc of movement has to be allowed for the design of linkages, otherwise the mechanism may jam. Whatever this is there, that is particularly designed, otherwise this whatever is there, this is the reciprocating motion. By this one, this will be more like this, it will be swing, it will be swing like the pendulum motion oscillation it is going to get. Okay, that's why it will be particularly designed, otherwise the whatever the this mechanism provided, that will be jams. Okay, that will not provide any movement. The next one is a rotary motion. When any object rotates about or spins about its own axis, that is called as exhibiting a rotary motion. Some examples of rotary motion include that one, the motion of the spinning top, the rotation of the earth and other planets about their own axis, and movement of the hands of the clock, gears, etc. Here we are taken the gear as a rotary motion mechanism. The gear is rotating about its own axis, and this mechanism is used in that machine to have any rotary motion and conversion of it. The next one is a ratchet mechanism. The ratchet mechanism consists of a gear and pole. This is the gear and this is the pole. and that allows the motion in only one direction. This gear to be rotated in only one direction. Other direction it will not possible. It whatever pole is there, that poles in the next step, and that will not allow to rotate in the other direction. And that ratchet mechanism used for the rotation in only one direction. In only one direction. As the ratchet rotates, the pole drops onto each steps on the ratchet rim. Okay, that ratchet rotates, the pole will be drops on each step on the ratchet rim. That will be there. Due to that one, the preventing the ratchet from the turning into the other direction of the pole. Sometimes spring is used to keep the pole in contact with ratchet. Here the spring may be used to in contact with the ratchet always. It will provide only one direction rotation. The example of this one, the rear wheel of the bicycle, which will operate in only one direction. Other direction it will take the load. Okay, that is the ratchet mechanism. Next one is clamping. Once a workpiece is located in any it is necessary to press it against the locating surface. In any surface it is located, it should be pressed there at that position on the surface and hold it there against the forces of acting upon it. And for that purpose there is a clamping device used. The tool designer refers to this action as a clamping, and the mechanism used for this action known as the clamps. Here this is the surface, okay, that some part is to be held, okay, by using the clamping plate, and here this mechanism, whatever is there, if it is pressed down, okay, this will be pressed against the surface so that it will be holds the surface, okay, firmly, that one. Okay, then that will be clamping, it will happens that one. Whenever this will be released and this part will be released, this force will be released from that one, the part will be removed from that one. By that one, the clamping action we can have. This is about the clamping mechanism. Next one, we are going to have the reverse motion mechanism. The reverse motion mechanism means, here in this one, reverse motion linkage are used to change the direction of motion. In one direction if you have the motion, then other direction if you want to get it, then this reverse motion mechanism we are going to use, and that can be explained here. Okay, here the one part, that is one link is there, at the center link it is pivoted at the center, okay, that one, and this is whatever the other third link is there. This link, if it is moving in the right direction, then this whatever the center part about the pivot, it will be rotate, then, and this the other link whatever is there, it will be moving in the opposite direction. A single lever with a pivot at center, okay, this is single lever which pivot at center, reverses an input motion, that will be reverses without affecting the input force. The force will not be changed, and that will be without effects, that one. Another way of describing this linkage is that direction of movement in one rod is reversed in the other rod. In one rod the direction of motion is there, that will be reversed in the other rod. That is the reverse motion mechanism. Where it is required, there we can use. The next one is a pause and hesitation. Pause or hesitation. The pause or hesitation motion producer appears to come to a stop for a short period of time. For a short period of time it is paused. Okay, it will be stopped there, and after that it will be continuous for its movement. Then the most obvious example of this type mechanism is that used to control the valves on an internal combustion engine. In the internal combustion engine valve we are going to use, okay, that is operated by this mechanism. The valve has to open and remain open for a fixed part of the cycle, and close and remain closed for the fixed part of the cycle. Okay, for that purpose it will be opened and that will be held at that position, and after that it will be closed and remain closed for a fixed part of the time. And for that reason we are going to use this pause or hesitation mechanism. The solution for this type of mechanism is used to cam controlling. For that the mechanism cam controlling is that the motion of the valve stem. The induction mechanism as described in the induction section can often provide the stop and dwell motions. Here induction mechanism, in case of that some machines like the milling machines, Okay, we are going to use this type of mechanism, and for this that cam operating, we are going to use the cam for operating of the valves. And this cam, whatever is there, that cam is, it will be for a particular time period, it will be remain open. Okay, then it will be lifted, that will be closed, and particular time period it will be remain closed, and that will be closed for that particular period, and for that period it will be stopped. That one, that is the faucet hesitation type of the mechanism. Then last one, loading and unloading mechanism. Here the mechanism what we are going to use is the different links we are going to use by forming a mechanism which will loads the any load onto the vehicle, and it can be unloaded also. For that purpose we are going to use this mechanism. A vehicle loading and unloading mechanism is an example for loading and unloading mechanism, comprising in combination of a body movable to and from the load carrying position and the loading and unloading position. Means to so move said body a dolly suspended from the chassis of the vehicle and having the movements and from operative and inoperative position means. Okay, here this is an example given. That one, the main thing is that one, the whatever the load is there at the ground, that is to be lifted and kept on the vehicle, that is the loading. And if the load is there on the vehicle, that is to be removed, and that is to be placed on the ground. Okay, this is in this direction, it will be loading. Okay, it consists of that whatever the parts are there. This is a truck, this is the chains what are used, bin mechanism is there, and linear actuator, and this is the bin. The bin whatever is there, that is to be loaded and unloaded. Here you can see that one, this is the bin loading, that one, the links, by the links it will be lifted, start lifted, and this will be lifted and kept at a particular position, and later it will be loaded on the vehicle. From the ground it will be loaded on the vehicle. And similarly unloading is carried out in the downward direction. Okay, this is the link will start moving in this direction, and that comes to in place position, and that will be places on the ground. Like this unloading will be taking place. Best example of this one, the municipal corporation, that is a garbage bin whatever is there, that is lifted and loaded onto the vehicle and unloaded and kept at that particular position. Okay, like that, whatever are there, those are called as a loading and unloading mechanism. With this mechanical linkages and that whatever the mechanism are there, those are completed, and you can watch the different videos of these elements of mechanical engineering by subscribing to my channel. Thank you.